What if we just found air on a planet that isn't Earth? Not a hint of rock, not a smudge of light in a telescope, an actual atmosphere on a rocky world sitting in its star's habitable zone, the region where temperatures could allow liquid water. Astronomers say they may have caught it in the act of leaking into space on a planet 48 light-years from here. If this holds up, it could be one of the most important exoplanet discoveries of the decade. But that "if" is doing a lot of work, and we're going to be honest about exactly how much. The planet is called LHS 1140b, a rocky world orbiting a small, cool red dwarf star. It's larger than Earth but still classified as rocky, not a gas world, and it orbits inside its star's habitable zone. Astronomers didn't photograph clouds or storms. Instead, they looked for something subtler: helium. Helium is such a light gas that if a planet has an atmosphere, some of it should be constantly leaking away into space, especially near an active star. Using sensitive instruments, researchers spotted a telltale signature consistent with helium escaping from LHS 1140b. That escaping helium is the indirect fingerprint of an atmosphere still clinging to the planet. It's not a direct photograph of clouds or a spectrum reading off the planet's air composition. It's more like seeing steam escaping from under a lid and concluding there's a pot of water boiling inside. Here's why this is actually really hard. Most rocky planets we've found around red dwarf stars, like the famous TRAPPIST-1 system, appear to have no atmosphere at all. Red dwarfs are small, but many are furious in their youth, blasting nearby planets with flares and stellar wind that can strip away any air a planet might have had, the same way a sandblaster can strip paint off a wall. So when we look for atmospheres on rocky worlds around these stars, the expectation for decades has been, don't get your hopes up. That's what makes LHS 1140b intriguing. If it really has held onto an atmosphere for billions of years, despite orbiting a red dwarf, that would be unusual and worth understanding. But detecting a wisp of escaping helium is very different from directly measuring what's in that atmosphere. Is it mostly hydrogen, water vapor, something else entirely? We don't know yet. Prior observations of this same planet using the James Webb Space Telescope have actually been contested, with some data suggesting a thick atmosphere and other analyses suggesting the planet could be airless. This new helium signal adds evidence, but it hasn't settled that argument. Why should you care about a wisp of helium around a planet you'll never visit? Because finding and confirming even one atmosphere on a habitable zone rocky world would reshape how we search for life beyond Earth. Almost every method we have for detecting signs of life on a distant planet depends on being able to read its atmosphere. The mix of gases can reveal water, oxygen, even hints of biological activity. If rocky planets around the most common stars in the galaxy, red dwarfs, can sometimes keep their atmospheres, that dramatically expands the number of worlds worth searching. If they generally can't, it means Earth-like habitability might be far rarer than we hoped, and we should focus our limited telescope time elsewhere. Right now, this discovery is exciting because it's suggestive, not because it's settled. The honest answer is, this could matter enormously, or it could turn out to be a false alarm once independent teams take a closer look. So what happens next? This finding has not yet been through full peer review, and it hasn't been independently confirmed by another research team, both of which are essential before scientists will call this settled. The next steps are clear. Astronomers need follow-up observations, ideally from multiple instruments, to verify the helium signal is real, and not noise or a statistical fluke. They'll also want a direct atmospheric spectrum, actually reading the light passing through the planet's air, to figure out what gases are really there, rather than inferring it indirectly from escaping helium. If future observations confirm a stable atmosphere, LHS 1140b becomes one of the best real targets we have for studying a potentially habitable world. If they don't, it joins the long list of tantalizing signals that didn't hold up. Either way, we'll learn something important about how common or rare atmospheres are on rocky planets around small, cool stars. So, did we just find air on another world? Maybe. Astronomers have spotted something that looks like helium leaking from a rocky planet in the habitable zone, and that is a genuinely exciting hint. But a hint is exactly what it is right now, not a confirmed atmosphere, not a confirmed habitable world, and definitely not confirmed life. Science works slowly and carefully, precisely so that when we do finally say we found it, we can actually trust it. LHS 1140b just earned itself a spot on the watch list. Whether it turns out to be one of the most important planets we've ever studied, or a quiet dead end, we'll only know once the follow-up data comes in.